Yep. So, hello everyone. Thanks for coming, and thanks to Siobhan and the organisers as well for allowing me to talk. Appreciate it, and it's also good to be here at Zalando as well. I come to a good few talks here, so it's great to finally be able to have the chance to present here. So, I'm sure everyone kind of knows what Dublin Bikes is. They've been around for a good few years now. They're also quite common in many cities around the world. So, for anyone who's maybe not familiar with them, not from Dublin, it's just Dublin's public bike scheme. So you can pay a subscription, either an annual subscription or I think a weekend one, and you can allow to use the service. So there's around 99 stations around the city. I think there's actually just one around the corner. There's about 1,500 or more bikes, and around 42,000 annual subscriptions, so it's pretty busy, especially at peak times, which is, sorry, just the microphone doesn't really like me, or maybe it doesn't like Dublin Bikes. So it gets pretty busy at peak times, so that kind of brings me on to my problem in a moment. The most important thing for this project and for the talk is that there's real-time data for all the stations available via an API. And also this data is available through Creative Commons as well, so you're free to use it and adapt it as you wish. So my problem started about a few years ago. So I lived down in Rathmines, and this is a picture taken from Google Street View of my local station up in Portobello. So I thought it was quite funny that I didn't even have to go up and take a picture when it was empty. Google did it for me. It's completely empty most of the time. And if I'm just trying to get to uni in the mornings, it's kind of frustrating, and I usually end up getting the bus. So not too useful. I didn't really get much out of my subscription back then. So my motivation was really to kind of find times where, when is a good time to go and get a bike, really, because they usually were gone by about 9 o'clock when I'd be going there. So my girlfriend said, and I think the natural question is just why don't you get up earlier? And so I said, no, I can solve this with Python and data in the spirit of this evening, but I'm quite lazy as well. So I basically sat around collecting loads of data using from the API, and I'll go into a bit more detail on that in a moment. So that's going to be part one of the talk. Part two and onwards is going to be kind of around what I found. So, what kind of insights did I find? There's going to be a bit of machine learning thrown in there as well. More generally, though, we're seeing a lot of these APIs become available now. I know you can get it for public transport in other cities and bikes as well in other cities, but there's a wealth of data out there, and it all fits around transport and the future of smart cities. So I actually gave a talk similar to this one in Belfast last week, and the theme was all about smart cities and the explosion of data and what we might be able to do with that. Finally, I hope as well, I said before, it could be a template for people to use for their own projects. So it's all around citizen data science and how we might be able to use the data that's available to ask questions of the authorities and provide a bit of insight into how our cities are functioning. So that brings me to part one, which is all around gathering the data. So I have a Raspberry Pi sitting at home. There's Eric, I think, he's my friend in the audience here, said that I would never use it. So I'm finally able to say I actually did find a good use for it. There's an API which you can get the data from, which I mentioned, which is CityBikes API. So using the Raspberry Pi, I set up a short Python script to scrape the data from there every 2 minutes. I'll go into a bit about the data format in just a moment as well. So I was able to collect this overnight. I was able to collect this every 2 minutes, build up a little table for how many bikes were at each station at different times in the day. And then overnight at 1 in the morning, I would just upload that to an S3 bucket. So there's a bit more about the data that's coming from the API. So we have, it's going out in a JSON format. So we've got an example on the left-hand side there. So bikes is 15, got the station name, Fenian Street. A few more details about the position as well, which should be important later when we come to mapping this, and as well a timestamp. And so we basically collect all that data every 2 minutes and throw it into a table like that on the right, and we just keep sticking it on the end. The data is fairly basic as well. For Dublin, we only really have how many bikes are at each station. We don't really have information on the bike user level, which some other cities do provide, and I think there's been a few privacy issues around that. So yeah, maybe the Dublin situation is not so bad after all. So a bit more detail about how I scripted this, because I know there's a lot of beginners probably wondering, how the hell do you do this? Obviously, there's a lot of libraries imported, which always helps. Python's good for that. So main libraries I use for the scraping, it'd be JSON, requests. So requests is for HTTP requests, like web scraping and stuff like that. Requests is quite good for that. As well, the main library that I found useful for this project was something called pandas. So this is for, it's a data manipulation library. I'll show you a few examples of how I use that in a moment. But I'm a professional data scientist. It's pretty much my bread and butter. So it's a really, really good one to learn if you're thinking of going into data analysis or data science or to go into these kind of data projects. Pandas is fantastic for that. When I was scraping the weather data, I used a library called PyW API, which is a Python weather API. It allowed me to get the data from Yahoo Weather, and I think a few other weather APIs as well. So I had real-time weather data for Dublin. Didn't end up actually using that for anything just yet, but you know, if I was kind of there making the effort to scrape all that data, might as well get weather as well. So for the overnight bit, it was fairly straightforward. I used a little bash script for this. So use AWS CLI, which is the command line interface for AWS. And you can just write a short script, like on Linux or on a Mac or probably Windows as well. You can push this daily CSV I was building up to the S3 bucket. And you can schedule both jobs to run on the Raspberry Pi using Linux's cron. And basically, it sat by my sofa from January. I forgot about it, and I remembered again in August. So I have a lot of data there. So that's probably 7 or 8 months or so worth of data, so every 2 minutes. So it's quite a lot there. So on a practical note, there's, I guess, something to mention around resampling time series. So this is a bit of a dry topic, so I do apologize for that, but it might be interesting for anyone who's handling time series. So the problem is when you schedule a job to run every 2 minutes, it doesn't run exactly every 2 minutes, at least not the way I did it. Probably there is a way to make it a bit more precise, but if you look at the left-hand side, I've got this timestamp, so 14:02:02, and the one that's supposed to be exactly 2 minutes later is actually just a couple of seconds too late. Looking at the bikes at Fenian Street. When you have all this data available, you can use something called resampling. So this is it's kind of like for filling in gaps or interpolating, or maybe you're trying to create a very precise structure for your data, which was my main, the main thing I was trying to do with it. So you can convert what you've got on the left-hand side there, which is probably quite awkward to work with, and obviously as time goes on, if you look at the day after, this slight time difference is just going to compound and get worse and worse. So it makes it much easier to just use this resampling method. You get something like on the right-hand side there, nice and structured. Every minute I've got a measurement, and I've used this that short bit of code there as well, which would do that transformation. So I was saying before I use pandas, it's my bread and butter. This is a great example of how it's very good. It's very easy to do this sort of stuff. So if you haven't used it before and you work with data, definitely give it a look. Make your life a lot easier. So now all the data has been collected, I want to move on to a bit of analysis. So coming back to my question is, how early do I have to wake up to get a bike at Portobello Harbour? Unfortunately for me, it's extremely early and probably a bit too early for me, to be honest. I'll stick to the bus. So if we look at the graph here, on the x-axis we have time between midnight on one night and spanning all the way to the following midnight. So I built this by taking an average over every single weekday in the data set. On the y-axis there, we've got the capacity of the station in terms of how full it is. So if it's nearly 100%, all the bikes are there. 0%, there's nothing there. So you can see by about 8 o'clock, I'm out of luck, really. I've got to get there pretty early. I think an interesting point about this is, despite my experience where we're often finding there's no bikes there at all, you can see on this graph it's not actually quite 0. It's probably around 10% during the middle of the day. I think this could be due with the weather. When it rains, people don't really want to cycle. I think that might be a possible explanation. Like I said, I haven't had time to actually look. I have the weather data, but I probably need to do a bit of analysis around that. So anyway, not good news for me and getting to college in the morning. But we can do a lot more with that, though. I have measurements going back, 7 or 8 months for all the stations in Dublin. So there's a lot I can do with that. So for example, we could look at the system profile for the average weekday. So on the x-axis, we have the same thing again, just an average weekday, midnight to midnight. On the y-axis, we have the system usage in some very kind of badly defined arbitrary units. Basically, the bigger the curve, the more busy I've defined the system to be. So you can see peak times, well, commuting times, 8 till 9 in the morning, and then we're looking 5 o'clock-ish in the evening. There's a peak in the middle of the day, which I think is quite interesting as well. I was a bit surprised by that. I imagine it's people going to lunch, maybe they're going to meetings in the afternoon, going to meet friends, maybe they're just going home for the day. So yeah, that was a little bit interesting. You can look at weekends as well, showing a vastly different profile. So yeah, so far it's fairly simple. I want to look a bit more deeply into this though. This graph's a complete mess, I know, but bear with me, I'll make my point. So again, on the x-axis we have this time, the average weekday, the usage of the bike station for the day. Y-axis is the capacity again. So I've plotted all 99 stations on this graph, and you can see, it's not particularly insightful at first. But my argument is if you squint and you look you can kind of see there's maybe different groupings of station profiles. It would kind of make sense that stations that are on the outside of town, they're going to be used for people commuting into work in the mornings. I mean, I know from looking at Portobello Harbour, it seems to be like that would have a big dip in the middle of the day. There are probably similar stations that fit that pattern. And you can say there are opposite stations as well, where they may be in the middle of town, and these are the repository for bikes coming into the city. And so maybe there are two different profiles there, maybe there are more. And I wanted to do a bit of investigation into this and see, what can I turn up, what's interesting. So we move to part 3, and this is all around clustering of time series. So I want to digress slightly, just to introduce you to a fairly simple algorithm. I do my best to explain it. It's probably don't have enough time to probably explain it in full, but I'll give you a general gist of it. So imagine we have the data on the right-hand side there. So we've got 2 dimensions and a bunch of points just scattered around. So I'm going to use a method called k-means clustering now. So k-means aims to partition all this data into k different groups. So it could be one group wouldn't be very helpful. It could be 2, it could be 3, it could be more. This is called an unsupervised learning problem because we don't actually know how many groups there really are. We're trying to ask the algorithm to figure this out for us. And so it can be quite nuanced depending on the type of problem you're working on. For a simple example, we could say, looking at that as a human, there are 2 groups, the 4. If you want to be controversial, I guess you could say 3 as well, 2 at the top, 1 at the bottom. K-means clustering is extremely easy to implement with Python's scikit-learn. So some of you might know about that. Scikit-learn is Python's machine learning library. So it makes a lot of these algorithms like k-means or simple regression classification algorithms. They're very easy to implement, very easy to work with. So if I was to apply k-means to that last data set, and I asked it, okay, can you find me 2 groups in my distribution of points? It picks something like this. So we have a red group at the top and the blue group at the bottom. And so the x's are designating the kind of the center of the cluster. And so points are assigned to the nearest cluster center that they are to. You can also ask it for k equals 4. Again, like I said, you can pick any number for k. So for k equals 4, we get something slightly different. So brings me on to something like, how do you exactly decide how many clusters you have? Because surely for my problem with Dublin Bikes, I'm trying to cluster time series. It's maybe quite a difficult problem. I've said before, if you squint and look, maybe you have 2, but that's not very quantitative and not very rigorous. So there's a method called the elbow method, which I'll just go into a bit of detail here. So I think it's very simplistic, and you'll probably see why in a moment. So it's a heuristic approach. It's the posh word for the rule of thumb. Basically, you kind of look at things, and if things are, you just look at things. So you calculate the sum of squared errors, which is the average squared distance between each observation and its assigned cluster centroid for each k value. And this is always going to decrease as well. And basically, when you graph this, like on the right-hand side, you're going to look for the kink. So on the y-axis, we have this sum of squared errors, and the x-axis, we have the number of clusters. So I think the kink is indicated there by the arrow. So the elbow point is where k equals 4. Basically, this means that if we're trying to add any more clusters from k equals 4, it's not really going to substantially improve the clustering using this sum of squared errors metric. So the problem is when you actually apply that to real-world data, it does never work, almost never anyway, I'm sure. So yeah, lesson learned, don't really rely on it, please. You can be a lot more rigorous than that, though. Here I used something called silhouette scores. So the approach is a little bit more complicated, but still, I think, fairly easy to understand, really. So it's just a score between -1 and 1. Again, you're going to graph this for all your different k values. So +1 is very good. It's great. -1 is pretty bad. Might want to go back to the drawing board. And 0 suggests you've got clusters that are overlapping. I don't think we really want to go into the maths. But it's not too complicated, but I'll skip over it anyway. So we compute the average of this silhouette score over all observations, and then basically we're going to pick the k, which gives the highest score. So I've done it on the right-hand side there for the data that we have. You can see k equals 2 gives the biggest silhouette score. It's around 0.43, which isn't great, to be honest, but I'll take it. Not too fussy. We apply k equals 2 to our data set, and I think this is kind of the, where things get a bit more insightful. So when I ask the k-means algorithm to take the data that I've gathered and apply k equals 2, it comes up with these two profiles. So again, this is the average weekday usage, and I've got two different profiles. I've got my green one and my red one. So my green one looks a bit like Portobello before, where people are using it to commute into the city. They're taking bikes from it. It's leaving it empty during the day. And we've got the red group there as well, which exhibits the opposite trends. It's the repository for all these bikes. This is a closed system. We have a finite number of bikes. Bikes have to go between one place and the other unless they get thrown in the river, which hopefully doesn't happen too often. But anyway, we have two very distinct groupings there. And if we go a bit more with the mapping, you can see there is there's a massive divide in, there's massive spatial segregation in how the stations are dotted around the map. So if you remember, the green ones were the ones that people use for commuting in, and the red ones would be the kind of the repositories for that. So you can see there's a massive spatial segregation going on there, which is quite interesting. It really does highlight kind of where people are living, where people are going to work, and I guess it's biased by the actual people who have subscribed to it as well. And so I created this map. It's an interactive map as well. I did host it online. I used a library called Folium, which is a Python wrapper for leaflet.js, which is really, really good. Folium as well is great. It makes doing it easy. Definitely encourage you, if you have any mapping problems, definitely give it a look. I was blown away with just how good stuff looks, really, for someone who I definitely don't know any JavaScript, so it made my life a lot easier. As well, OpenStreetMap for the mapping as well. It's quite a good resource. But I originally did this actually with k equals 3, simply because I thought it looked cooler. So again, we have our two profiles from before, the green and the red profile there. So I've thrown another one for the blue one. So remember, the using the silhouette scores, k equals 3 is probably not the most scientifically rigorous and correct way of doing it, but it's my personal project, so I get to choose. So anyway, the blue one kind of doesn't fit either. It's kind of pretty much steady through the day, and I will kind of show a plot of how all the stations compare to their assigned profile as well in just a moment. So when you go to plot this, this is what I thought was very cool. You still have that spatial segregation going on. Okay, there's probably there's a red one kind of on the north side there around some blues, but you still have the segregation effect going on, which I think is really surprising and really, really cool. So to say how good it is, I know we've tried the metrics before, but it's also good to take a look at your data as well, see how you're doing. So on the left-hand side, we've got the green stations. So we had 46 stations out of the 99 that were assigned to the green one. So I've indicated with the dark green line the kind of the archetypal profile, or the kind of the cluster centroid for the green type stations. And with maybe you can actually see that. Yep. So with the faint green lines, yep, they did come out okay. So the faint green lines are from all those 46 stations. So you can see from eyeballing it, that's not bad. It's pretty good. We definitely see that there's a big kind of tight band of them, especially in the morning, and then in the evening, it kind of definitely the stations can diverge in their patterns a little bit. Similar story for the 32 stations for the red profile as well, and for the blue profile, it's all over the shop. No surprises there. I guess it's maybe indicating that it's not so bad to use k equals 3. We definitely have a lot of stations which don't really fit into either the green or the red group. So that brings me almost to a close, really. Conscious that I might have been very quick, so I apologize. I'm sure we're all eager to get a beer or two. So what did I learn from the project? Mainly I need to wake up a lot earlier. Probably not going to happen. Secondly, historical data is really hard to come by. Like, as a practical point, I think if you're a professional data scientist, you usually have a lot of data available to you for your company. But when you come to do this as just a member of the public, it's actually really hard to get historical data. Like, you can lodge freedom of information requests. I did a while ago, never heard back. So don't always kind of hedge your bets on that. So you can always collect the data yourself. So I hope me showing you how you can use like a Raspberry Pi, or even simpler would just be to use an AWS EC2 instance. I guess if you want to get really clever as well, you could use AWS Lambda as well, which could be another alternative as well for doing this kind of job. So I had a few comments from people as well, and this brings me back to what I was saying about being about citizen data science and how we can maybe use this data to get more transparency in our public services. So just read a few of them out there for people who are maybe at the back. So top guy here says, very interesting. I would use Dublin Bikes far more if the distribution was better. typically 0 out of 120 available near his office most days, and he's tweeted to the council that as well. I think a few people, myself included, we tweeted to the council, we didn't hear anything back. I'm sure they saw it, so I'm a bit disappointed, but can't win them all. Next one says, in case you're wondering where Dublin Central Business District was, it's where those blue and red dots are. It's the south side oriented city, so I know people probably have their own thoughts about that. The next one, so up to Dublin Bikes to equalise the balance by moving bikes around. I suppose traffic gets in the way, so I do want to point that out. Like maybe my my complaints about Portobello might have been a bit too harsh, because at the end of the day, you know, this is run with the council, and they obviously are doing it in the public interest as well. So I think fair comment. You know, there are definitely restrictions around it. It's not simply a case of more bikes, more stations. So if anyone's thinking of looking at this project, I'll show the GitHub link in just a moment. As I said, the data is available through Creative Commons, and my code is all on GitHub as well. So if anyone wants to kind of take a look, maybe see what their own station's like as well. It's okay, actually. Actually, I might need the link, actually. Yeah. Sorry, I think it's all the mic though. God, I've forgotten completely what I was saying. Okay, yeah. So other things you could do with the data, besides looking at how your own station has been as well, you can look at things like resupply times. So we have that data again daily, every 2 minutes. I was simply trying to take an overview by looking at the average weekday profiles. The effects of weather, I collect all that weather data too. You can do some look at predictive modeling as well. Thought as a future project, you can make like an API or something for like a local station, or all the stations. Could be kind of a cool project. As well, it is my obligation as a professional data scientist to say, don't really use k-means for time series clustering. I did for this because I thought I got good results, but generally you probably want to use something more exotic. There's something called dynamic time warping, which is pretty good. Didn't have a chance to implement it with this because I got okay results from k-means. I was happy with that. But definitely think about using this for own projects. Use k-means, it's easy, but also consider something like dynamic time warping as well. I don't really tread on that, but it's pretty good. It's a much more robust way of clustering time series, and much, much more. So thank you very much for listening. Here's links to my GitHub and my Twitter and my blog as well. Thank you.
So I'll just try and get those links up on the screen there. Yay. So does anyone have any questions? Who would like to start? I'm thinking about dynamic time warping, and you're saying that this might be a better method. Can you see anywhere in the time? So one of the things with dynamic time warping is it's good at catching time series where it's in cycles, right? But they might be out of sync. So if two people have the same pace when they're walking, but they're out of sync or walking at different times, it can still capture that clustering. And I'm wondering, did you see that in the cycling data when you were looking at it, or did you get to eyeball it that much?
It's been a while since I looked. Oh, sorry. It's been a while since I looked at it. I've used dynamic time warping during my job as well. Like it's pretty robust. I'm trying to think of the best Python implementation of it. Actually, I don't think it's in scikit-learn. Sorry, I've gone down a bit of a rabbit hole here. Yeah. Sorry.
Oh, no, you're fine. I guess the other question would be, speed-wise, how do you find dynamic time warping?
It's pretty slow. K-means is fairly easy to implement as well. And I think it's important as well, like if you have an algorithm that's kind of easy and kind of works well for your problem, like it did here, it's definitely a good thing. Yeah.
And then, sorry to hog it, but do you use I don't know if it's worthwhile doing this. We can play catch. But what would you use Euclidean distance, or what would you recommend with dynamic time warping, or even k-means? So, like, do you have a go-to distance metric for a time series?
Distance is probably the easiest to explain to people and to understand. So, honestly, that's the only one I've really used in practice. Although I know there's definitely more exotic kinds, like Minkowski distance, I think is one you can use.
Yeah. But I guess if it works, what's the point in complicating it, right? Yeah. Yep.
Hi. Thanks for the talk. It's very interesting. One thing, maybe I missed it, but I didn't see any specific difference for weekends rather than working days. Was there something that you noticed there?
I'll go back to my slide to address that question.
So I missed it, sorry.
Oh, no, no worries. So, I got it one too far. This would be weekdays versus weekends. Maybe I skipped over this a bit too quick. So the red dash line there is for weekends.
Okay.
So you can see it's a vastly different profile there. Like people are mainly using it around the afternoons. There's definitely not many people commuting on a Saturday and Sunday. So there definitely are, but probably the minority of people. As well, you can look at this on Saturdays and Sundays. They also show different trends. There's slightly less usage on a Sunday in general. So yeah.
And then another thing, sorry, as I have the cube here. So, no, I read your blog when it was a couple of months ago. It was out.
Yeah, I think like maybe a month or 6 weeks.
Yeah, I thought it was very good, right? The idea was great. But then, this made me think, because I was walking to work and I saw that they were replenishing a bay with the new bikes. So there is a lorry that I've seen more than once that takes bikes from a place and puts them on another one. How does that interfere with your analysis?
So why I took an average over such a long time, but it was a nice fact. The fact that I forgot about my Raspberry Pi running turned out to be a blessing, because I think taking the average over like so many months on all of the weekdays kind of smoothed it out. If you definitely start looking at the profile of stations on a more granular level, you can definitely see that. Another thing you don't get actually with this is it's a bit of like a small problem with this. Actually, I think this graph probably explains it. Actually, no, so I'll go back to Portobello. So one thing that you will miss with this as well is because I'm only querying the API every 2 minutes, you do miss times where bikes can come in and be immediately taken out again, which is, can be, I wouldn't say it's too much of a problem, but it's definitely a practical issue. Like the 2 minutes I used, I think was the kind of the API usage cap. If you get any more than that, I think they clamp down on your usage quite a lot. So there was that consideration for that, definitely.
Thank you.
Thanks.
So one question I have is, so one problem is, for you, if you get up too late, you don't find bikes there. But something that I have seen is, especially in the science gallery one, is that people, when they come back from work as well, there is no place for leaving the bike anymore.
Yeah.
So they are walking with the bike to find the next bay. And have you found anything like that? And is there anything in your data as well, or is that a problem that can be solved somehow by addressing what you have found?
That's a really good point, because it's a problem I had just a couple of days ago. Like, thankfully I was only waiting for, 5 minutes, so it wasn't too bad, but it certainly is a problem. It's nothing you can really see with the data. Like, we only are able to see how many bikes are at each station. So I know some of the other cities around the world, I mentioned New York and London, so they would have information about individual bikes. So they'd have down by the ID going between which station and the other station, how long it took. And I'm sure if you had detail on the data on that level, you might be able to do something around that. Maybe look for abnormally long travel times. But then I guess you have other problems, like people stopping at the shop might cause that method to go completely out the window. But it's certainly a problem, like I've noticed from a user point of view, and I'm sure Dublin Council are aware of it as well. Like I wouldn't care to hypothesize what the correct solution for that would be. I'm sure there are quite a few. I wouldn't be able to think of any good ones on the spot. Maybe like just more, having more of the docking stations could be good. Maybe they could look at other cities and see what they've done to solve the same problem. So.
I wanted to ask whether you have data on the individual bikes, but I think you just answered this question
unfortunately
before.
not.
So
I think New York and London, I think I mentioned there. I think they do, or at least they used to. There was an article a while ago, I think, about the privacy issues surrounding that if you were able to, you might be able to identify certain people because they have like unusual habits that can show up in the data. It might be like they might go to work in a very remote place. They might live in a kind of slightly remote place, and they might commute to work at 4 in the morning. I think there were maybe issues around that. They may have had to get rid of making that data public, perhaps. Okay. But yeah, it certainly would be very helpful to have data on that level. But as well, unfortunately in Dublin we don't have that. Sure.
Scattered. That's the effect on this clustering, because you can, if there is a station which is really, really far, so people will go there to park the bike because there's no nearby. So that can also affect the results of this clustering.
Yeah, I definitely agree with that. I'll just go back to the map so we can kind of see the distribution of the stations around the city. I think this is almost all of them, because I was cropping the picture. I think a couple are maybe cut off at the top and on each side, actually, come to think of it. So yeah, definitely when you go kind of out west, they seem to be a bit more scattered around, and I think you're right, that definitely would affect the results. I'll be hoping that if this data is freely available to the public, I imagine the council probably have people in-house who have access to all the historical data, maybe on the kind of bike level as well, which maybe they would consider publicizing at some point. Yeah. So, any more questions? Oh yeah, Grania, hi. Sorry, could you say the first bit again? I definitely make my code a lot cleaner in case any of you look at it, because I might get crucified later. The data gathering was pretty simple. The one thing I would change actually would be the weather API I used. I don't think Yahoo Weather is the greatest. I should mention, I work for a utilities company, so I'm used to looking at weather data, and I know there are better sources out there than Yahoo Weather, especially for places in outside of the US, weather data can be not the best. I have an app on my phone. I got rid of it actually because it's so bad. I think it was AccuWeather, something like that, and it would always tell me oh, it's not raining, it's sunny or something, and it was always, of course, it was bloody raining. So it didn't last too long. But yeah, I think something like Met-Aaron definitely have a lot of historical data, but it's the source I've only have access to through work. And it's only because we're a utilities company, weather affects quite a lot of what we do. Yeah, as far as public weather data go, I'd probably spend a bit more time trying to find a good source of it, really. Probably Weather Underground would be my go-to for anyone thinking about using weather data for their projects. So.
Give James another round of applause. Thanks a million for your talk. And actually, all of our speakers, thank you. I really enjoyed all of the talks this evening.